In this video, we are going to introduce the roots of complex numbers. Let's start with an example. Okay, now the question says find the fourth roots of -4 minus 4i. Now, the question asks me to find the roots. So this means I'm going to find 4 distinct, different roots. Here is how. I'm going to use this formula to find each root. Now let's examine this. We have p as the number of roots. Here it is given as 4, so p will be 4. And we have n. Now n changes up to p minus 1. Now in our case, n will be starting from 0 and going up to 3. There are 4 values of n. So for each value of n, I will do a separate calculation to find separate values as roots. So that's the idea. Of course, before we start, we have to change our rectangular form into polar form, which we need to find r, we need to find theta. So let's start solving. When we calculate r, we find square root of 32 and theta to be 5 pi over 4. Now, for p is 4 and n is from 0 to 3, the 4 values, let's substitute all the values and get a general form of our roots. Now, in this formula, we will substitute p to be, say, 4. So let's do the substitutions. It will be 1 over 4 here, divided by 4 in these cases. Our r is square root of 32. Now we can write this as 32 to the power 1 over 2 to the power 1 over 4 actually. So we can just multiply these powers and find 1 over 8, which means the 8th root of 32. We will fix that in the next step. And for theta, we can write 5 pi over 4, so let's do that. It will be 5 pi over 4 for each case, each function. And the only thing left is n, which we are going to substitute separately. So our formula looks like this. It will be 32 to the power 1 over 8 times cosine of 5 pi over 4 plus 2n pi over 4 plus I sine 5 pi over 4 plus 2n pi over 4. Now each time I substitute n, 0, 1, 2, 3, I will get a distinct separate root from this calculation. So let's see how. Okay, now for n equals 0, what happens is that we have this part to be 0 because we multiply by 0. So the root will be 8th root of 32 times cosine 5 pi over 16 plus I sine 5 pi over 16. If the question asks you to convert this to rectangular form, you will just do your calculations for cosine and sine and find approximately 0.86 plus 1.28i, together with, of course, multiplying your calculations in here with 8th root of 32. So this is what happens when you do the substitution and find the root. Next, we have n equals 1. When we substitute 1, this is what happens, and when we fix it up, we have 8th root of 32 times cosine 13 pi over 16 plus I sine 13 pi over 16. For n equals 2, when we substitute 2 instead of n, we get at the end 21 pi over 16 here in the calculation of the angle. So the third fourth root will be 8 power of 8 root of 32 times cosine of 21 pi over 16 plus I sine 21 pi over 16. And finally, when we have n equals 3, after doing the calculations, we get 8th root of 32 times cosine 29 pi over 16 plus I sine 29 pi over 16. So of course what I show in here you have to show separately, and each one should be on your work, so it will be a long question to solve. And of course I didn't change these polar coordinates into rectangular forms. If it is asked, you also have to go through all these calculations and find the rectangular forms as well. Though it is a little bit long process, all we have to do is we will substitute the values and do some calculations to find the distinct roots. Now is your turn. So in these two questions you're going to find, well, here the cube roots of 2 plus 2i, here the fifth roots of 4 root 3 minus 4i. So cube root means we have p to be 3, so n will be 0, 1 and 2, and the fifth root means p will be 5 and n will be from 0 to 4, which we have 5 roots. Now I would strongly suggest you here that convert your polar roots into rectangular forms for practice, because here it didn't ask us to find it, but it may be the case. So please, after finding the roots in polar form, change them into rectangular form, and please show your work to me.